Hello, in this lecture we will find the radius of the circle enclosed in a triangle. We have a triangle ABC, side AB of the triangle equals to 4 units, side BC of the triangle equals to 3 units, and side AC of triangle ABC equals to 5 units, and inside the triangle we have a circle, and we want to find the radius of this circle, and we also know that the area of triangle ABC equals to 6 units squared, and in the first step we will define the center of this circle as O. So point O is defined as the center of this circle, and then the touching point between side AB of the triangle and the circle will be defined as N, or we can say that side AB of the triangle is tangent to the circle at point N, and the touching point between side BC of the triangle and the circle will be defined as M, or we can also say that side BC of the triangle is tangent to the circle at point M, and also the touching point between side AC of the triangle and the circle will be defined as P, or we can also say that side AC of the triangle is tangent to the circle at point P. Okay? In the next step, we will connect together by a straight line points N and O. And we will also connect together by a straight line points O and M. And we will connect together by a straight line points O and P. So actually those line segment NO, line segment MO, and line segment PO are the radiuses of the circle. So I will mark them as arm. Okay, and the reason that those line segments are the radiuses of this circle is because a radius of any circle is defined as a line segment that starts from the center of the circle and ends at any point on the circle itself. And actually the line segments NO, PO and MO satisfy this definition of a radius because all those line segments starts from the center of the circle, that is to say from point O, and ends at a point that on the circle itself. For that reason, line segments NO, line segments PO, and line segment MO are the radiuses of this circle because they start from the center of the circle and ends at point that is a point on the circle itself. For that reason, those line segments are the radiuses of this circle. So I mark them as small r. Okay, and actually we have a rule. I will call it rule number 1. And rule number 1 states that in any circle a radius and the tangent to that radius are perpendicular to each other. So I will read rule number 1 again. Rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius, let's call it R, and we have a tangent to that radius, let's call it T, then the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So in any circle, a radius and the tangent to the radius are perpendicular to each other. So we actually can implement rule number 1 in our circle, because actually we have 3 radiuses of the circle and we have 3 tangents to those radiuses, and according to rule number 1, the radiuses are perpendicular to the tangent. So for example, line segment NO is the radius of this circle. We have a tangent. AB is tangent to the radius. For that reason, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees, because the radius is perpendicular to its tangent. For that reason, this angle is 90 degrees, and also this angle is 90 degrees. Okay? And for the same reason, line segment MO is the radius of this circle, and side BC of the triangle is tangent to this radius. For that reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. Okay, because the radius is perpendicular to its tangent. For that reason, this angle is 90 degrees, and this angle is also 90 degrees. And in the same way, we can say that side AC of the triangle is tangent to the radius. OP is the radius of this circle, and side AC is tangent to this radius. For that reason, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees, because the radius is perpendicular to the tangent AC. For that reason, this angle is 90 degrees, and also this angle is 90 degrees. Okay? So, actually, in the next step, we will connect together points O and B by a straight line. And we will connect together also points O and C by a straight line. And we will connect together by a straight line points O and A. And as you have already know, the area of any triangle, the formula for the area of any triangle is actually equals to the base of the triangle times the height to the base all divided by 2. Okay, so actually the formula for the area of any triangle is equals to the base of the triangle times the height to the base, all divided by 2. This is the formula for the area of any triangle. Or instead of the area of a triangle, we can use the capital letter A, that is the abbreviation for area, and we can write down that the A, that is the area of a triangle, equals to the base of the triangle times the height to the base divided by 2. Okay, so actually this is the formula for the area of any triangle. The base times the height to the base divided by 2 equals to the area of a triangle. Okay, so actually we can use this formula in order to calculate the area of triangle BOC. Okay, so we will calculate the area of the green triangle BOC so the area of triangle BOC will be equal to the base of the triangle. The base of the green triangle equals to 3 units times the height to the base. The height to the base of the green triangle equals to the radius of the circle, because the radius R creates 90 degrees with the base. For that reason, the radius is the height of the green triangle. So it is 3 times the radius divided by 2. That is the area of the green triangle BOC. Okay? So the area of the green triangle equals to the base, that is 3 units, times the height, that is the radius of the circle, divided by 2. Or 3 over 2 equals to 1.5. So the area of the green triangle BOC equals to 1.5 times the radius of the circle. Okay? In the same way, we can calculate the area of triangle AOC. Okay, so the area of the yellow triangle that is triangle AOC will be equal to the base of the triangle that equals to 5 units times the height of the yellow triangle, that is actually the radius of the circle, because the radius creates 90 degrees with the base. Okay, angle OPA equals to 90 degrees and angle OPC equals to 90 degrees. So because of the fact that the radius creates 90 degrees with the base, the radius is the height of the yellow triangle. Okay, so it is the base, that is 5 units, times the height, that is r, divided by 2. Or the area of the yellow triangle, triangle AOC, equals to the base, that is 5 units, times the height, that is the radius, divided by 2. 3 over 2 equals to 2.5. So I write it down. So the area of the yellow triangle, triangle AOC, equals to 2.5 times the radius of the circle. Okay, and in the same way we can calculate the area of triangle AOB, that is actually the orange triangle. So actually the area of the orange triangle, triangle AOB, will be equal to the base of the triangle, the base of the orange triangle, that equals to 4 units, times the height of the orange triangle. The height of the orange triangle actually equals to the radius of the circle, because the radius creates 90 degrees with the base. For that reason, the radius is the height of the orange triangle. So it is 4 times the radius divided by 2. Okay, so the area of the orange triangle equals to the base of the orange triangle, that is 4 units, times the height of the orange triangle, that is actually equals to the radius, because the radius creates 90 degrees with the base. For that reason, the radius is the height of the orange triangle. So it is 4 times the radius, all divided by 2. 4 over 2 equals to 2, so we can write down that the area of the orange triangle equals to 4 times the radius. Okay, so actually uh, we know that the area of triangle, the big triangle ABC, equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Or in other words, the area of triangle ABC equals to the area, to the sum of the areas of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that equals to 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. So in total, the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle equals to the area of the big triangle ABC, because actually triangle ABC contains those three triangles, and the sum of the areas of those three triangles equals to the area of triangle ABC. Okay? So we can summarize. So I will call this equation number 1. The area of the big triangle ABC equals to the sum of the areas of the three triangles. We can summarize this side of the equation. 1.5r plus 2.5r equals to 4r, and 4r plus 2r equals to 6r. So in total, in this side of the equation, we have 6r, and 6r equals to the area of the big triangle ABC. But we know it is given us in the question that the area of triangle ABC equals to 6 units square. It is given us in the question. Okay, the area of triangle ABC equals to 6 units square. So we can substitute the area of triangle ABC by 6, because the area of triangle ABC equals to 6 units square. So we'll substitute the area of triangle ABC by 6. So 6 equals to 6 times the radius. So we can divide equation number 1 by 6, and we will get that the radius of the circle equals to 1 unit. Okay? So the answer to the question is that the radius of this circle equals to 1 unit. Okay? Now I will summarize the lecture. Actually, we wanted to find out the radius of the circle enclosed in triangle ABC, and we know the sides of triangle ABC. We know that side AB of triangle ABC equals to 4 units, and we also know that side BC of triangle ABC equals to 3 units, and side AC of the triangle equals to 5 units. And we also know that the area of triangle, the big triangle ABC equals to 6 units squared. Okay? And we want to find out the radius of the circle enclosed in the triangle ABC. Okay? We actually defined the center of the circle as point O. and the touching point of side AB with the circle is defined as N. The touching point between side BC and the circle is at point M, and the touching point of side AC with the circle is at point P. So actually side AB of the triangle is tangent to the circle at point N, side BC of the triangle is tangent to the circle at point M, and side AC of triangle ABC is tangent to the circle at point P. Okay, and we actually connected together points O and M by a straight line. We connected together points O and M by a straight line, and we connected together points O and P by a straight line. And actually those line segments, line segment ON, line segment OM, and line segment OP are the radiuses of this circle because of the fact that they start from the center of the circle and ends at a point on the circle itself, and for that reason they are the radiuses of the circle, because the definition of a radius is any line segment inside the circle that starts from the center of the circle and ends at any point on the circle itself. It is the radius of a circle. For that reason, line segments ON, line segment OM, and line segment OP that starts from the center of the circles and ends at a point of the circle itself are defined as the radiuses of the circle. Okay, and we also have rule number 1 that states that in any circle a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, we called it R, and we have a tangent to that radius, we called it T, then the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, so we can implement rule number 1 in our circle, because in our circle we have 3 radiuses and 3 tangents to those radiuses, and for that reason, according to rule number 1, they are perpendicular to the radius. For example, we have this radius, ON, line segment ON is the radius of the circle, and we have side AB that is tangent to the radius. For that reason, according to rule number 1, angle ONB equals to 90 degrees, and also angle ONA equals to 90 degrees. And we have also line segment OM that is the radius of the circle, and we have also tangent to that radius. Side BC is tangent to that radius. For that reason, according to rule number 1, angle OMB is 90 degrees, and also angle OMC equals to 90 degrees. And in the same way, we have line segment OB that is the radius of this circle, and we have tangent side AC that is tangent to the radius at point P. For that reason, according to rule number 1, angle OPA is equals to 90 degrees and angle OPC equals to 90 degrees, because the radius is perpendicular to its tangent. For that reason, this angle is 90 degrees and also this angle is 90 degrees. Okay, and in the next step, we connected together points O and B. We also connected together by a straight line points O and C, and we also connected together points O and A by a straight line. Okay, and in the next step, we actually know that the area of any triangle equals to base of the triangle times the height to the base, all divided by 2. Or instead area, we will write down the capital letter A, that is the abbreviation for area. So the A, that is the area of the triangle, equals to the base of the triangle times the height to the base, all divided by 2. This is the formula for the area of any triangle. So we use this formula in order to find out the area of the green triangle. The area of the green triangle equals to the base of the green triangle, that is 3 units, times the height to the base, that is actually the radius of the circle, because the radius creates 90 degrees with the base. So the area of the green triangle equals to 3 times the radius divided by 2. Okay, or 3 over 2 equals to 1.5, or the area of the green triangle equals to 1.5 times the radius. Okay, in the same way we calculated the area of the yellow triangle, that actually equals to the base of the triangle, that is 5 units, times the height of the yellow triangle, that is the radius. The radius creates 90 degrees with the base. For that reason the radius is the height of the yellow triangle. So in total we got that the area of the yellow triangle equals to the base times the height, that is the radius, all divided by 2, or the area of the yellow triangle equals to 2.5 times the radius. Okay, and we also calculated the area of the orange triangle. The area of the orange triangle equals to the base of the triangle, that equals to 4 units, times the height of the triangle, that equals to the radius of the circle, all divided by 2. Or the area of the orange triangle equals to 2 times the radius. Okay. But we know that the area of triangle ABC, the big triangle, equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle, because of the fact that the big triangle ABC contains those 3 triangles. So the area of triangle ABC equals to the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, so we can write it down as equation number 1. Actually, equation number 1 says that the area of triangle ABC equals to the sum of the areas of the 3 triangles, the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, so in total we got that the area of triangle ABC will be equal to actually 1.5 to 2.5 equals to 4R. 4R plus 2R equals to 6R. So the area of triangle ABC will be equal to 6 times the radius of the circle. But we have already know that the area of triangle ABC equals to 6 units square. So we can substitute the area of triangle ABC by 6, because it is, the area equals to 6. So we got that the end that 6 equals to 6 times the radius. We divided the equation number 2 by 6, and we got that the radius of the circle equals to 1 unit. And that is the answer to the question, that the radius of this circle that enclosed in triangle ABC equals to 1 unit. Okay, thank you very much.